We spend hours poring over the specs of flashlights, days agonizing over what duty belt will wear the longest, and months researching what air freshener will overpower the funk that's found its way into our unit's interior. But how much do we know about the tool we use to process point clouds and diagram crash scenes? Stick around to find out how our computers work and how to get the most bang for your buck when it's time to buy a new machine. The reason we're discussing this today is getting the right computer for 3D diagramming of crash and crime scenes is tough and often misunderstood for most law enforcement agencies. Now, we wanted to tackle this topic to help everyone out, even if you aren't a user of the Trimble forensic solutions. Let's start off with looking at what the major parts are of our computers: the processor, memory, hard drive, and graphics. Each of these components are connected together using a main board inside of our machines. Now, the hard drive sends data to memory to stage until it's fed to the processor. After that, data goes out of the processor to the graphics, to RAM for holding, or written to the hard drive for long-term storage. Each one of these components can be thought of as a pipe. The bigger the pipe, the more data you can shove through in a given amount of time. You can buy a huge pipe for most components, but if you put a constriction anywhere in the loop, you can only push as much through as the smallest pipe can handle, and the key to getting the most out of your purchase is to have everything in balance. It doesn't do much good to buy a $2,000 processor if it's bottlenecked by a $75 hard drive. Now that we have an idea of how these components work together, let's look at each part in detail. We'll start with our hard drive. Now, there are two basic types of hard drives: the spinning platter and the solid state. The spinning platter drives have, for decades, been a mainstream in computer PCs. Cheap, reliable, and able to store massive amounts of data for next to nothing in terms of cost. But they have one problem: they're slow. Point cloud data requires a lot of loading and unloading of data from the hard drive, and when this occurs, mechanical hard drives struggle to keep up. Enter the solid-state drive, or SSD. These drives are much faster when it comes to reading and writing because they're microchips with no moving parts to physically spin or slide in a position to read and write data. But not all SSDs are created equal. SSDs generally come in two different interface options: SATA and NVMe. Here's a comparison of typical hard drive speeds. You can see that the NVMe drive is going to blow the doors off a typical spinning hard disk. These drives come at a cost, however. Their speed is offset by the storage capacity at the same price point. This brings us around to another storage option: the USB drive or flash drive. These drives, although they're solid state, are quite slow. The way to work with them is the same with a spinning hard drive. When you're ready to work on your data, move it to your NVMe drive. Do your work, and then move it back when you're done. Moving on to our memory, or RAM. RAM is very fast, capable of pushing 25,000 megabytes per second. Now that's equivalent to 5 DVDs every second. Now, RAM comes in different speeds, and you'll pay more for faster memory. However, DDR3200 RAM is the tipping point where price versus speed game begins to drop off. Now, when we talk about RAM capacity, your needs may vary. However, in my experience, it's rare that I hit the top of my 32 gigabyte capacity, and that's with a bunch of browser tabs open while working with a 100 scan data set. Typically, 32 to 64 gigabytes will be more than sufficient to handle whatever you can throw at it. Now, if you need more, desktops usually allow you to upgrade your RAM later without having to buy a whole new machine. Now, all that speedy RAM is used to feed your processor, or CPU. The processor's job is to take software commands and execute them, and the faster it can do that, the better. Now, the two things you'll see when shopping for a processor is core count and clock speed, typically expressed in gigahertz. Let's tackle core count. A core is a processing unit that can execute code. Now, you may be thinking more cores are better, right? Well, sort of. All these cores can only work when the programmers write their code to use all the cores at once. Many times we want to spec machines with monster 64-core processors, only to put them to work on a task that uses a single core. The happy place seems to be around the 8-core, 16-thread area when it comes to price versus performance gain. Now, this brings us to the other part of the equation: clock speed. If core count is how much a processor can chew, the clock speed is how fast it can chew it. Generally, higher is better. That brings us to the topic of cooling. Now, the trend right now is to buy thin, lightweight laptops that are trendy, portable form factors that come at the cost of speed. Processing this data generates a lot of heat, which isn't able to be dissipated by the thin, lightweight laptops and power supplies. They cope with this by reducing speed and power to stay within thermal limits, something that desktops typically don't have a problem with, especially if you opt for a desktop with liquid cooling. Now, in terms of price versus performance, desktops will get you much more bang for the buck, sometimes saving thousands for the same or better performance. One way to balance portability with speed is to have a high-powered desktop in a fixed location. Then use your laptop to run a remote desktop session. All the heavy lifting is done by a desktop while you're free to roam on an inexpensive laptop. Lastly, we have our graphics processor, or GPU. Now, while you may think that the latest bleeding-edge gaming card is what you need, you may be surprised. A modest graphics processor in the $300 to $400 range is usually more than sufficient for drafting and point cloud workloads. As you can see, there's a lot to these machines, and all too often department IT staff have a tough time understanding the needs of point cloud and 3D diagramming workloads. What's well suited for word processing and writing citations is often very underpowered for the needs of processing of laser scan crime scenes numbering in the billions of points. Now, the best advice we can give is to look for a gaming machine. Most departments have purchase contracts with major computer manufacturers that sell a line of consumer gaming PCs and laptops that are ideally suited for 3D mapping workloads, yet are oftentimes cheaper than a similar spec corporate workstation. Hopefully this video has been helpful in understanding what is inside of our machines and what to ask for when it's time to get a computer for processing point clouds, 3D diagramming, and UAV photogrammetry. Now, if you have any questions or comments or have something that you would like to see on our channel, put it in the comment section below. See you all next week. Stay safe.